Hello friends, welcome back to the bench. So today is the day we're gonna actually do the test on our new controller, and that is gonna be real life test. We're gonna remove the CPU socket. Now I received a lot of advice from you guys regarding the thermocouple, and indeed I ordered two more, but one from China, one from Australia, so it's not gonna be here for a while now, but I can freely very quickly replace the thermocouple as I need. I haven't figured out any way to actually place it on the board, but one thermocouple that I ordered is a kind of a ring, so I can just literally screw it onto the board. That will give me the actual temperature of the board, or a lot more reliable temperature reading from the board. And now this one, as I mentioned, and as you guys advised me, this one has a very large, or comparably very large thermal mass, because it is designed for much more heavy equipment, stuff that heats up very slowly and keeps the temperature for very long. Now it is a PID controller. That was the question in the comment as well, and indeed it does state in the documentation that it's a PID controller, so it does overshoot, as we saw, to one if it's set to 100 degrees, it would overshoot to 108 and then stabilize it. So this is normal, that's how it works. So we just need to be aware of that it's going to go a few degrees above. Now, replacing the sockets, the CPU sockets on the motherboards, that is something that it's not very basic, right? There's a lot of factors, and one of those factors is stable temperature and accurate temperature. Now, I do have a board that we're going to be working on maybe tomorrow, maybe a little later. I'm just going to keep in it for the time when my hands are really steady. I removed the socket from the board that was working otherwise. About a few pins were broken, but other than that, because these were ground and VCC or V-core pins, so the CPU would still work, but obviously you shouldn't use it like that. So I removed the socket, but what I observed is that first, it wouldn't heat up to the temperature I usually set it to, and the board is slightly deformed, so overheating. On one hand overheating, on the other hand not hot enough, because when I removed the socket I ripped about 5 pins, one of them not connected, so that's fine. So about 4 pins we need to repair, 4 pads on the board. So that's going to be step number 1, and step number 2 to replace the socket. And now, as far as my observations so far and my procedure of replacing the socket is, I turn on the preheater. I preheat the board, or at least until now I was preheating to about 130 degrees, which is the maximum temperature that this heater was capable of achieving before modification. Then I set 300 degrees on the nozzle. I lower the nozzle like so. Then I wait for the board around the nozzle to get to 250 degrees. Once it's at 250 degrees, I lift the nozzle and remove the socket. So that was my procedure. That worked really well on 2 boards, but that third board, both the signs of both overheating and underheating are visible. What I expect happened on that one is I did not remove the heat sinks, and the heat sinks on this particular board, because I tried that before without removing the heat sinks and it worked perfectly fine. But on this board, I expect that heat sinks are just better, bigger, and they just won't let the board heat up to the temperature I wanted. But the temperature in certain spots, certain spots was too high. So that's why the board both shows signs of overheating and underheating. Very weird case, but we'll get to that. So our plan now is the thermocouple will go under the board in the center of the heater. The board is also in the center of the heater, and I have two bolts over here that go into these two holes that I drilled over here. We have aluminum foil on both sides to just kind of keep this temperature underneath the board. Now the thermocouple will go here in the center. That's where we measure the temperature. Then I will set the temperature on the controller to, I don't know what temperature yet. It's gonna have to be higher because the board is gonna have lower temperature than the temperature underneath. So I'm not sure, maybe around 200 degrees, and that'll bring the board to 130. I don't know, we'll see. We're gonna be observing with a thermal camera and adjusting the temperature as needed. And that's it. Let's try and test our board repair equipment built by Black Horse Repairs.
We are dreaming in the dark. We are nothing more than dust. Search but you stay lost. We are reaching for the stars, but we're making this too hard. And I wonder where you are. Mysterious, that's the part you always show. 'Cause you're too curious. Maybe you should take it slow. Mysterious, that's the part you always show. 'Cause you're too curious. Maybe you should take it slow. We're dreaming in the dark. We are nothing more than dust. You search but you stay lost. We are reaching for the stars, but we're making this too hard. And I wonder where you are. Mysterious, that's the part you always show. 'Cause you're too curious. Maybe you should take it slow. Mysterious, that's the part you always show. 'Cause you're too curious. Maybe you should take it slow.
Alright, so it's not bad for the first try. There's no signs of overheating of the board, no warping or anything on either side. Yeah, everything looks good here. However, we did melt the socket, but just tiny bit. And it appears that, because it's only slightly melted over here, it didn't even deform. It's just the side of the socket over here inside that melted enough that it made a mess over here. So that would be, I mean, you can clean it, but it's a pain. Once this plastic melts, it's a pain. So that shows us that the temperature is actually too high, because we don't want to bring it to the temperature where the socket would start melting. Not to mention the smell now. My whole shop now smells like melted plastic, and it's gonna smell like that for 2 days now. What are you gonna do? So I was using airspeed 3. This is 3 out of 8, at least on this machine. So I'm gonna reduce the airspeed to 2.5, or maybe even to 2 with next try. While keeping the temperature at, the temperature was 198, 197, at least set on this. The board never got to 250 outside the nozzle. And I don't know why can I not replicate that anymore. I was thinking of that something with the nozzle, because I did do some more work on it. Maybe I introduced that, but the socket melted mainly because it was taking too long. It shouldn't take that long. Now, as far as the preheater did great. It's still even slightly hot. The temperature that I need to set for the bed is around 220. That gives me around 130 on the board. This is so far just one test, so it's not too reliable yet. But the good news is that there is no warping of the board. You know, even if when we remove the socket, even if we melt it, you know, it's not a huge deal. It's not a huge issue, other than, you know, added time for cleaning the melted plastic. But as long as the board doesn't suffer any warping, we're good. So we didn't overheat it, but in one place it was overheated. So I'm thinking 2.5 maximum for the airspeed, and maybe I'll drop to 290 even, you know, and we'll see how that will go. But I wouldn't call that a success, but I would call that a very nice start. Not sure what this is. Oh, right, yeah, I remember. I was hooking up to I was soldering on the wire on this one to see on the scope how the voltage is rising. I remember this board. Yeah, this is for parts. It's already missing some transistors. So, you know, even if we overheated this one, I wouldn't cry too much. But no ripped pads. I can see that this side had the most issues. This here, most issues getting hot. That is understandable, because that's where our little gap is. A little crack through which the air can escape. So this is understandable that this took the longest. But no ripped pads and no warping. So that's good. That's not bad for the first try. Now we'll try with another board before. So first I want to make sure that we can remove the socket without melting, and I actually already knew that this was going to melt and this wasn't going to work because I saw the smoke. You should not see any smoke doing this unless you put flux on it, because yeah. And I know you're probably gonna recommend to put flux on it to kind of even out the temperature and make it easier to desolder. True, that would probably produce better results, but it produces a lot of smoke, and you don't know if it's not too hot. Plus, you need to heat it up first, then lift the nozzle, then put the flux. If you put the flux first, then by the time the board is hot enough to melt solder, all the flux will already have evaporated. On top of that, the flux will burn because we are heating it up very high to the pretty high temperature, so the flux, depending on the flux you use, but if it's RMA, low temperature, it will burn. And it is also pretty difficult to clean the burned flux, especially RMA. So yeah, maybe I'll try with flux. I don't know. We'll try a few combinations. So far, this is not looking bad. The main test was for the bed and temperature control of the bed. The temperature seems pretty stable. It heats up correctly. The board heats up to the temperatures I wanted to heat up to. And actually, maybe next time, I think I will increase the temperature of the board, because that's going to make it a lot easier. And sometimes even 5-degree difference is the difference between the successful job and a failed job. You know, it can be, yeah, that threshold is somewhere. You know, it's not like it works in 135, so it'll work in 130. No, that 5 degrees could be that threshold between whether it's going to work or not. So we'll see. As far as my updates, I did have an interview this morning. MedTech, CRM, something like that. It's kind of, if your domain is PHP, then you're gonna work with a lot of CRMs and stuff. But I'm gonna interview for them next week. So far, it's just my resume is going there, and we'll see. Maybe I'm not even gonna get a call back. I don't know, but we'll see if that goes well. I might take that job. As far as the open source job, yesterday finally the lady responded to me, and I saw on Slack her status was out sick, so that's understandable why the delay was there. So she said they need 3 to 5 days to review my work. It's kind of they probably have like a lot of started processes, and that's why it takes so long. Because in my view, it shouldn't take more than 15 minutes to review everything. It's but we'll see if that one falls through. Then maybe this medtech will work out, which is it's also remote, and the money works for me. It's not exactly at the level I would want to, but it's perfectly acceptable. I would even work for less, so it's fine. So we'll see. But that's pretty much it. Well, that was our Friday partially failure, partial success. So let's call it a Friday success. And I will start prepping another board, and maybe I'll just repeat the process off camera, adjusting based on today's failure, and I'll just report next time, or maybe I'll just record it and show you guys the recording. In any case, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.